Okay class, today video is about the linear independence and dependence. If we are having two solutions, here just say y1x and y2x, and we want to check whether these two solutions they are independent or they are dependent. So the combined equation of these two solutions we can write in this way. We have a constant a and the first solution y1 of x plus another constant and the second solution. So if this combined equation, if it is not equal to 0, then in that case the two solutions y1 and y2 they are independent of one another. But if this combined equation is equal to 0, so in that case these two solutions are dependent. So there is another way of checking out the independence and the dependence of the solution, so which is being given by the round scan method. So the round scan method will give you W stands for the round scan, and here you have two solutions, that is y1 and y2, and in this case y1 and y2 they are the function of x. That's why we write here x. Now we have a matrix which is a 2 by 2 matrix, and we can see that this is a function, the first function y1x, and this is the derivative, is a first order derivative of y1, and here we have y2, and this is the dash stands for the first order derivative of y2. Now we have a 2 by 2 matrix, and we need to find the determinant of this matrix. So if we find the determinant of this matrix, then we will write in this way. You have the y1 of x and y2 prime of x minus y1 prime of x and y2 of x. Now if this w is equal to 0, that means the two functions y1 and y2 will be dependent. But if w value is not equal to 0, then y1 and y2 are said to be independent. Okay, now let us try to take one example, and let's try to find out whether these two functions, whether they are linearly independent or dependent by using the round scan method. So let's say y1, let y1 be e of x cos of x, and y2 be e of x sine of x. And we can see that both y1 and y2 is a function of x. And now y1 prime, so which means y1 prime, which means we need to differentiate y1. So if we differentiate y1, we will get here, simply it will be, if we differentiate e of x, we'll get here e of x and cos x plus e of x. If we differentiate cos x, it will be minus sine x. Why? Because this is a product of two functions. So if we differentiate it, then this is how we'll get it. And in other words, y1 prime is equal to e of x cos x minus e of x sine x. Okay, and y2 prime. So if we differentiate y2, then here in that case we'll get a c of sine x plus e of x, and if we differentiate sine, it will be cos x. So we already know what is your y1, y2, y1 prime and y2 prime. So let's try to put in a round scan method. So we know that w is equal y1, y2, and which is a function of x, is equal to y1 and y2, y1 prime and y2 prime. So if we try to put this value, then we have y1 is nothing but e of x cos of x, and y1 prime is e of x cos x minus e of x sine x. Again, y2 is e of x sine x and e of x sine x plus e of x cos x. So it's a 2 by 2 matrix. Let's try to find out the determinant. Then it will be e of x cos x and e of x sine x plus e of x cos x minus e of x sine x, and here it will be e of x cos x minus e of x sine x. Now we can multiply that. In this case, what we can see, okay, all right, we can just do it in this way. If we multiply this way, it will be e of 2x cos x and sine x plus again e of 2x cos x and another cos x minus e of 2x sine x and cos x plus e of 2x sine x and sine x. Now, if we check properly, here we are having e of 2x cos x sin x, e of 2x cos x sin x, but this is plus and minus, we can cancel out, and this one we can write e of 2x cos square x plus e of 2x sine square of x. Or in other words, we can write this e of 2x command and cos 2x plus sine 2x. Well, we know that cos square of x plus sine square of x is nothing but 1. So in that case, your w is equal to e of 2x. Now we can see that the Wronskian w, which is not equal to 0. So in this case, y1 and y2 are called linearly independent. So this is how we try to check the linearly independence and dependence of two functions y1 and y2 by using the Wronskian method. Okay class, we are going to take another example by using the Wronskian method and solve some equation. In this case, we are going to do three things. The first, we need to find the Wronskian determinant, and the second, we need to verify that the solution satisfies the differential equation, and the third, we need to show by Wronskian test the solutions are independent. So we already have the two functions y1 and y2, and this is a differential equation. Now the first thing, we need to find the Wronskian determinant. So that's number A. So how to find the Wronskian determinant? We already know y1 is equal to e of 2x and y2 is equal to e of 3x, and we can get y1 of prime. So if we differentiate, it will be e of 2x. Here if we differentiate 2x, we'll get here 2, and here y2 prime, we will get here 3 e of 3x. Now let's try to find a Wronskian. W is equal to y1, y2, which is a function of x. We have y1 prime, and y2 prime. And let's try to find the determinant. Better put the value of y1. y1 is e of 2x, and here 2 e of 2x and e of 3x, 3 e of 3x. So if we try to find out the determinant, then we'll get here 3 e of 2x and e of 3x minus 2 e of 2x and e of 3x. Then we are going to get here 3 e of 5x minus 2 e of 5x, and which is equal to e of 5x. So your w is equal to e of 5x. So we have already solved the first one to find out the Wronskian determinant. So this is w is nothing but a Wronskian determinant, and we already got the Wronskian determinant as e 5x. Now let's try to solve the second one. In the second thing, what we need to do is that we need to verify that the solution satisfies the differential equation. So what are the solutions? Here y1 is one solution and y2 is another solution, and this is a differential equation. So what we need to do is that we'll try to put the first solution in the differential equation, and we are going to check it out whether the left hand side is equal to 0 or not. And the second time, we are going to put y2 in the differential equation, and we are going to check whether it will give you 0 or not. Now, for question B, let's try to check for this y1. For y1 is equal to e of 2x. Now instead of y, we are going to put y1, but this is y prime, so this is a first order derivative, so we'll put y1 prime, then it will be 2 e of 2x, but this is a second order derivative, so we'll differentiate y1 one more time. So y1 double prime is equal to, we'll differentiate it 4 e of 2x. Now let's try to put a value of y1 prime and y1 double prime in the differential equation. So we have y double prime minus 5y prime plus 6y is equal to 0. So we need to check this differential equation for a given solution y1. So this will be your y1, and y1. So y1 double prime is 4 e of 2x minus 5. y1 prime is 2 e of 2x plus 6. y1 is e 2x, which is equal to 0. Now which implies that this is 4 e of 2x minus tan e of 2x plus 6e of 2x. Now we can see that 6 plus 4 is tan e of 2x minus tan e of 2x is equal to 0. So this is 0 and this is 0. So which means left hand side is equal to right hand side. So which shows that the given solution y1 e2x it satisfies the differential equation y prime minus 5y dash plus 6y is equal to 0. So y1, the first solution, y1 satisfies the differential equation. Why? Because left hand side is equal to right hand side. Now let us check for the second solution. We have y2 is equal to e of 3x, and even for y2 we'll find out that y2 prime is 3 e of 3x, and y2 double prime is equal to 9 e of 3x. Now we already have a differential equation, which is y double prime minus 5y prime plus 6y is equal to 0. So in that case, we are going to put y2 instead of y, so it will be y2 double prime minus 5y2 prime plus 6y2, which is equal to 0. Now if we see, well, continue here. If you see, y2 double prime is nothing but your 9 e of 3x minus 5 3 e of 3x plus 6 e of 3x, which is equal to 0. So this is your 9 e of 3x minus 15 e of 3x plus 6 e of 3x, which is equal to 0. 9 plus 6 is 15 e of 3x minus 15 e of 3x, which is equal to 0. 0 is equal to, so which means left hand side is equal to right hand side. So even for the second solution y2, it satisfies the differential equation. So in this case, both the solution y1 and y2 satisfies the differential equation. So we can write that y1 and y2 satisfy the differential equation. So 1 and 2 is already been done. So the first one was to find the Wronskian determinant, so we already got it. And the second, we need to show that the solution, that is y1 and y2, satisfy the differential equation. So we have already shown that both y1 and y2 satisfy the differential equation. And the third, we need to show by Wronskian test the solutions are independent. But we have already seen in the Wronskian determinant that w is equal to e 5x, so which is not equal to 0. So in that case, we can say that y1 and y2 are linearly independent. And this is how we try to solve by using the Wronskian method.